Howdy and good day, fellers. We are wrapping up CO17 with absolute value inequalities. We went through this page of notes. We talked about how a less than symbol means that it is within 5 numbers from 0 or within 8 numbers from 0, and therefore it's an and statement. I gave you my nifty little tidbit, less than symbol. It's an and statement. Then we talked about the greater symbol and the fact that this one, would mean that x is further than or more than 15 from 0. So it's going to be an or statement. And the whole top of this page here was prepping how to get from the absolute value inequality to the compound inequality so you can solve it. And me being old, I already forgot. Did we do any of the 4 down at the bottom? Yes. Which ones did we do?
1 and 3.
The first and third? The ones, okay, yes, because the extra stuff. All right. So, we should have the first and third ones finished. Our goal for this is to isolate the bars, right? And then rewrite it as a compound inequality. So for this one, the bars already being by themselves. I'm not going to go over all of it, but the inequality that we would write is negative 12 is less than x plus 7, which is less than 12, right? That's saying that x plus 7 is within 12 of 0. And then you solve this to find what value for x makes x plus 7 within 12 of 0, okay? The third one, we had x plus 10 is less than negative 15, or x plus 10 is greater than 15, right? That one told us that whatever x plus 10 is, it's further than 15 away from 0, and breaking it up in the or statement allows us to figure out what the ranges are. I think it was less than negative 25 and greater than positive 5. That would make x plus 10 more than 15 from 0. Okay. So if there's other stuff going on, like in that second one, the absolute value of 3x minus 6, that minus 6 being outside of the absolute value bars means we have to get rid of it first. Okay. We can't go to our compound inequality until the bars are by themselves. What do you think we should do? Elise? Opposite operations, add 6 to both sides. We get the absolute value of 3x is less than 21. And we're good to go, right? And statement or statement? And statement. It means that 3x is between negative 21 and positive 21, or it's within 21 from 0. So our inequality statement is going to read negative 21 is less than 3x is less than 21. Okay. The hardest part of this is probably going from the inequality or the absolute value inequality to the compound. Okay. But there is a format pattern. Take a look at the 2 and statements that we have here. Do you see any similarities from our original inequality? And I'll go from this one here because that was the bars by themselves. The original inequality to our compound. Do you see any similarities, patterns, connections, interesting quirks? Elise? Okay, with the less than symbol, it's an and statement, which is the less than symbols. It showed that it's between. But take a look at what's inside of the absolute value bars. That x plus 7 doesn't change here, right? We just take the bars off, but it's still x plus 7. This 3x didn't change either, just without the bars. Okay? And then tell me about the 12s and the 21s. Is there any sort of connection there, that format pattern that we can look at here? Elise?
On the left, it has a negative number, and then on the right,
Yeah, essentially what we're doing is once the bars are by themselves for an and statement, we're taking what's inside of them and just putting them between the positive and negative value of our solution side, right? The absolute value of x plus 7 is less than or equal to 12. So negative 12 on the left, positive 12 on the right, x plus 7 in between. The absolute value of 3x is less than 21. Negative 21 on the left, positive 21 on the right, and then 3x is in between. Okay, so if you are a patterns type of person, a formula type of person here. If you've got the absolute value of x is less than y, and don't write this down if this is going to confuse you, okay? It's just another way to kind of help you visualize this. But for any absolute value inequality, the absolute value of x less than y, your compound inequality is going to be the negative value of y is less than x, which is less than the positive value of y, right? If y is 12, negative 12, positive 12, okay? If y is 21, negative 21, positive 21. And then whatever's inside the bars just goes in between. If that doesn't help you, don't write it down. I don't want to confuse you more. If it does help you, then there you go, okay? But from here, we have this compound inequality to solve. And we're going to do that using opposite operations. To isolate x, we're dividing by 3, and there are 3 sections to this. We need to divide all of them by 3, and we get negative 7 is less than x, which is less than positive 7. Okay. Our graph shows that x is between negative 7 and positive 7, and any value within that range will make the original inequality true. So someone give me their favorite number in between negative 7 and positive 7. Erica. 3. If we plug in 3, we've got the absolute, I'll do it up here. The absolute value of 3 times 3, right? 3x, but we're plugging in 3, minus 6, that's supposed to be less than 15. Okay, 3 times 3 is 9. The absolute value of 9 is 9. Is 9 minus 6 less than 15? Yes, it is. 3 is less than 15. So we know that we're right. Okay. Questions on that? The only extra step that we did today compared to yesterday is literally just move that 6 over. Everything else was exactly the same. Okay. The fourth one, also stuff. Okay. We've got 2 times the absolute value of x minus 9 is greater than or equal to 20. This is going to be an or statement, right? Greater. And that 2 being outside of the absolute value bars, we would distribute. Yes? No. I tricked you. You cannot distribute into absolute value bars. Okay? Absolute value bars are strong, sturdy. They cannot be penetrated. Okay? So instead, what do? If we can't distribute, what's the other option? Divide by 2, right? Because this says 2 times the absolute value of x minus 9. So dividing by 2 undoes that, and the 2's cancel out. Okay? The absolute value bars don't go anywhere, though, because they aren't afraid of anything. They hang around. Parentheses, they're weak, they're timid, they would go away, but not absolute value bars. And so we get 20 divided by 2 is 10, and here is our absolute value inequality that we're going to write as an or statement and then solve it. Okay? So going back to kind of the preliminary graph that we worked with yesterday, what this is saying right here, right now, is that x minus 9 is further than 10 from 0, meaning it's on the left side of negative 10, or it's on the right side of positive 10, right? It's more than 10 away. As a compound inequality, how we write that, and I'm going to give myself a little more space here, okay? We would say that x minus 9 is less than or equal to negative 10, or x minus 9 is greater than or equal to positive 10. I made it. Like we did with and statements, do you see any connections, patterns, quirks with our original inequality statement and our or statement that we write? Any format patterns that you might be able to use to help you set these up? Thumper. Right. What's inside the bars doesn't change, right? X plus 10 is x plus 10 here, it's x plus 10 there. X minus 9 is x minus 9 there, and x minus 9 there. And the same is true with the ands, right? Whatever's inside your bars, whether it's and or, does not change when you set up the compound inequality. What changes, because it's that absolute value, it's that distance from 0, is this 12, because it's how far away it is from 0. And there are two sides to 0. Same thing here. Okay? Yeah, Gabby.
So do you not have to separate the value from, like if there's two values inside the absolute value bar, do you not have to separate the value from x?
No, it's just get the bars by themselves. X doesn't have to be by itself inside the bars, so whatever's inside of them needs to stay. And then this greater than 15, well, notice how one side of it is exactly the same thing, right? Greater than 15, greater than 15. The other side is just less than the negative value, less than negative 15. Here, greater than or equal to 10, greater than or equal to 10 doesn't change. On the other side, less than or equal to negative 10. So if this helps you, again, if you've got something like, I'll do it here, the absolute value of x is greater than y, okay, you know it's going to be an or statement. The format to set this up is going to be x is less than negative y, or, I'd put that in a dumb spot, run right into that there. X is less than negative y, or x is greater than positive y. That's your format here. Okay? What's inside the bars doesn't change. And for an or statement, it's just less than the negative and then greater than the positive. If that doesn't help you, don't write it down. Okay? I don't want to confuse anyone more. Yes? That can go on a help sheet because it's any formula can go on a help sheet, and that's like a formula. So yes, that'd be fine. And so can that whole section on the front side of this too, right? Not the solving part, because we didn't actually solve there, but the conversion to the compound inequality. Anyway, back to what we have here. We still need to get x by itself. So we have add 9 to both sides. Again, solving this separately here, right? We get x is less than or equal to negative 1. Add 9 to both sides on the other side. And we get x is greater than or equal to 19. So our solution graph, x is less than or equal to negative 1. X is greater than or equal to 19. Any value for x within either of those ranges will make the original inequality true. Okay? Quinn, give me your favorite number in one of those two ranges there. 0? 0 is actually going to be, yeah, not in that range. Negative 2? Okay. So testing negative 2, we got 2 times the absolute value of negative 2 minus 9. And we want to make sure that that is greater than or equal to 20, right? Negative 2, this is going to work, because negative 2 is right there. It's in our solution set. Negative 2 minus 9 is negative 11. So we get 2, why is it still in red? Oh, anyway. 2 times the absolute value of negative 11. Of course, what is the absolute value of negative 11? Positive 11, right? And positive 11 times 2 is 22. And I'm all over the place now. I'm sorry, but 22 is greater than or equal to 20. So it does check out, right? Even though we get a negative value within the bars, by definition, that negative 11, the absolute value of that is positive 11. And positive 11 times 2 is 22, which is greater than or equal to 20. Okay? Don't you miss when solving a math problem took up like this much space instead of this much space, right? We had this conversation in 7th grade too. It's like, and Mrs. Fimone does a fantastic job of giving you algebra concepts before you get to pre-algebra or algebra officially. But K to 5 math especially, once you get your 4 operations down and understand fractions and decimals, it's really just the same stuff over and over and over again, right? Once you get to algebra, there's just so much there and so much you can do with those things that it's just the opportunities explode. It's great. So, questions on either of those two? Okay, let's look at the second page. And your homework for Monday, I'll give it to you now if you want to work on it and don't overwork yourself. But basically these 7 questions. Okay, these 7 questions. Since you have the practice test in addition to this, I don't want to overload you too much. But these first 7 questions, the 6 absolute value inequalities and the first brain buster are homework for tomorrow. You can skip the rest of the page.
Okay.
Okay. We'll talk about the brain buster a little more in just a little bit. But of these 6, take a look at them. A couple of them are sneakily quirky. Are there any that you want to discuss? Lauren? The bottom middle. I picked that one too, actually. What's sneakily quirky about that one? You have the 6 minus 2x, and which means at some point you're going to have to divide by that -2, which of course brings in the whole flipping sign situation and everything like that. So this is a good one. We can't break it into our compound inequality yet because we have that 3 out in front. It is mathematically illegal to distribute into absolute value bars, so we are going to divide both sides by 3, cancel that out of there, and we get the absolute value of 6 minus 2x is greater than or equal to 4. What type of statement? Or, okay. We know that what's inside the bars doesn't change, so that 6 minus 2x isn't going to change, and that greater than or equal to 4 is going to be less than or equal to -4. Or, again, what's inside the bars doesn't change, 6 minus 2x, and then greater than or equal to +4. Basically saying that whatever 6 minus 2x is, it's further than 4 from 0. It's either on the less than side of -4, going left, or the greater than side of +4, going right. Okay? To solve each of these, split it right down the middle, and we go to work. Subtract 6 from both sides. That gives us -2x is less than or equal to -10. And here's where we get to divide by a -2, which means, yes, we do flip our sign. So we get x is greater than or equal to +5. Okay. Hopefully, once you get it in that or statement form, you're able to remember the steps to solve it. It's not too bad. It's just getting there is the new part here. On the right side, subtract 6 from both sides here, and we get -2x is greater than or equal to -2. Divide both sides by -2, so we get x is less than or equal to +1. And like we saw with other compound inequalities that we've dealt with, what essentially happens here? The act of dividing by that negative number and flipping our inequality symbols. Do we still have an or statement? We do. If you visualize x is greater than or equal to 5, that's at 5 going right. X is less than or equal to 1, that's at 1 going left. But what's this quirky about this here, Gabby? Right. They're in order in the sense that when you graph this, make sure that your +1 is on the left side of +5, because that's how a number line goes. But x is less than or equal to 1 and still going left. X is greater than or equal to 5 is still going to the right. So it's still going to be an or statement. So it's sneakily quirky in that you do divide by that negative coefficient, but it's nothing special. The same stuff that we've seen before happens here. You just have to remember to do it. Okay. What's the other sneakily quirky one? We're not going to do it, but just so you can maybe identify it. Thumper? This one here? Maybe. I'm talking more about like with the flipping of the sign. Yeah? The top right one. Yeah. Okay. That's another one where you'll have to deal with sign flippage. It's a thing. All right, one more you'd like to do together. Not the top right, not the brain buster, but just for funsies. Bottom left, okay. Ooh, this one doesn't look very fun at all. I should have said not that one either. Oof. All right. Well, the bars are not by themselves, so we got to do some prep work here. We've got a constant, so we're going to move that first. And I already don't like where this is going. Why would I put this one on here? What kind of mood was I in when I wrote this question? Man. So adding 13 to both sides gives us 5 times the absolute value of half x plus 3, and that's less than 8. And we do need to divide by 5 to get the bars by themselves. Finish this prep work here. And we get absolute value of half x plus 3 is less than 8/5. Where's the fun in that?
There is. There's a lot of fun in that.
I'm going to move my work to the one up above it just because I have to write a little bit larger than you probably have to, so you can all see it. But from this step, the bars are by themselves, so we are ready to go to our absolute value inequality. Which type will it be? An and statement, less than symbol. So that tells me that we've got negative 8/5 is less than half x plus 3, which is less than positive 8/5. You see it? Yeah. Basically what we're saying, what this says here is that half x plus 3 is between negative 8/5 and positive 8/5 because it is less than that distance from 0. Okay. If you want to convert to decimal form, that actually might be easier in this case because you are subtracting that 3. So what is the decimal value of negative 8/5? 1.6. Sounds all right. So negative 1.6 and positive 1.6, that might be the better way to go in this case. Subtract 3 from all 3 parts. That gives us negative 4.6, which is less than 1/2 x, which is less than negative 1.4. And in our next step here, when we divide by 1/2, what's the same as dividing by 1/2? Really, when you divide something by 1/2, what's actually happening to it? Not multiplying by half, you're multiplying by 2. You're doubling it. So when we divide by 1/2 here, use a calculator if you have to, but in your head, you're essentially doubling negative 4.6, which if you think about that as doubling 46 to get 92, it's going to be negative 9.2. And if you're doubling negative 1.4, double 14, that's 28, it's going to be negative 2.8. Okay? So there'd be your solution there. And then you'd have to graph it. But I'm out of space, so you can do it. Yeah. Wait till we get to systems of equations. Just wait. The fun is yet to come. Okay. Questions on this? All right. Let's talk about the brain buster a little bit here, because on the surface it seems pretty challenging. And not to say that it isn't, but I think if I explain it, it's going to make more sense what you're asked to do here. So you're looking for a value for n that is a solution to both the absolute value of n minus 2 is less than 1 and the absolute value of n plus 6 is greater than 7. Basically, what I'm looking for you to do here is to solve each of these separately, but then graph them on the same number line. Because what you're looking for, graph the first one like right there, which is, is going to be an and statement, right? Graph your or statement, your second one up above it, and I'm looking for where do those graphs overlap, right? Because your graph of the and statement will show the values for n that make that inequality true. The graph of your or statement will show the values of n that make that inequality true. But if you graph them right above each other and where they overlap, that will give you the values for n that are solutions to both of them. Does that make sense? Right? So if these were the graphs, and they aren't, so just, but if we had, for the first one, n is between 100 and 120, and then, did someone throw that at me? Are you mad that I'm assigning this? I'm trying to help you, people. Calm down. Okay? And then for your second one, if your or statement, maybe we have, n is less than 110 or greater than 130. Where in these graphs would the solutions to both inequalities be? Between 100 and 110, right? Because that's where these two graphs overlap. Okay? Anything in this range here is only a solution in the first one. Anything in this range here is only a solution in the second one. Anything here isn't a solution to either of them, right? Because there's no graph represented there. But where they overlap, those would be your solutions to both. So that's what this one's asking you to do. It's really nothing different than the previous 6, only what you're asked to do with those graphs and do with those solutions, analyze them just a little bit deeper. That's the new part there. Make sense? No more chairs thrown?
No.
At least not till systems of equations anyway. Okay. Yeah. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Why not? All right. That's how you math.